Hey everyone, this is Mrs. Hilt, and in this video we are going to go through some practice calculations with Newton's second law of motion using F equals ma. Please have out a calculator as well as something to write with so you can follow along with the calculations as well. The first thing that we're going to do is rearrange the equation to solve for each variable. So the first one is done for us, mass times acceleration. But now you guys need to solve for mass and solve for acceleration. Pause the video. When you're ready for the answers, press play. All right, so first off, solving for mass. We'll use F equals ma, and we need to get mass by itself. How we cancel out the multiplication between mass and acceleration is with division. What you do to one side, you have to do to both. So mass is equal to force divided by acceleration. For solving for acceleration, a very similar format. We need to cancel out the multiplication between mass and acceleration by dividing. What you do to one side, you have to do to both. Therefore, acceleration is equal to force divided by the mass. All right, you guys are welcome to use any of those equations, or you can use dimensional analysis, whatever you see easier. I just require that you show all of your work, including the units, with all of your calculations. All right, first one. A car with a mass of 1,500 kilograms accelerates when the traffic light turns green. If the net force on the car is 4.0 times 10 to the third newtons, what is the car's acceleration? Pause the video and try calculating this on your own. When you're ready to see how it's calculated and the answer, press play. Okay, the first thing that I will do with this is identify what they gave me. So we know that the mass is equal to 1,500 kilograms, and the force is equal to 4.0 times 10 to the third newtons. And we are looking for acceleration. So we can do two different ways of solving this. We could use dimensional analysis, and I'm going to show you guys that the first way because it shows how the units cancel out very nicely. You will divide by the mass, 1,500 kilograms. Kilograms cancels out. See the meters per second carry through for acceleration. And you would divide 4.0 times 10 to the third by 1,500. And you would get 2.6 repeating. And how you would do this with the formula, very similar. 4.0 times 10 to the third newtons divided by 1,500 kilograms. It just looks a little odd when you're dividing an n by a kg that you all of a sudden get meters per second squared, but the reason how that works out is shown with the dimensional analysis. All right, and if we are going to report this answer to the correct number of sig figs, it would be 2, because in 4.0 times 10 to the third, that is the least number of sig figs, and it is 2. So it is 2.7 meters per second squared. All right, let's try number 2. An automobile with a mass of 12,000 kilograms accelerates at a rate of 3.00 meters per second squared in the forward direction. What is the net force acting on the automobile? Again, pause your video, try calculating this one on your own. When you're ready for the work and the answer, press play. Okay, I'm going to do the same thing as last time and identify what they've given me. The mass of 12,000 kilograms and the acceleration rate of 3.00 meters per second squared. And we are finding the force. So this one's very straightforward. Force is equal to mass times acceleration. Therefore, we will be taking the mass and multiplying it by the acceleration. And when you multiply those two together, you get 3,600 newtons. And if we want to write that with the correct number of significant figures, we need to see which one has the least sig figs in the problem. 12,000.0 has 5, 3.00 has 3. So to be able to write 3,600 newtons as 3 sig figs, we are actually going to have to write this in scientific notation. So it'd be 3.60 times 10 to the third newtons is the correct answer with the correct number of significant figures as well. All right, one more problem. A baseball accelerates downward at 9.8 meters per second squared. If the gravitational force is the only force acting upon the baseball and it is 1.4 newtons, what is the baseball's mass? Now, there was a little typo in there with the and is, but we know that a force is given, an acceleration is given, and we're finding mass. So go ahead, pause the video, and try solving this on your own. When you're ready for the work and the answer, press play. All right, so again, acceleration, let's outline that, 9.8 meters per second squared. Got force, 1.4 newtons, and we want to know the mass of the baseball. So we can use our formula that mass is equal to force divided by acceleration. We could also use dimensional analysis, 1.4 kg times meters per second squared divided by 9.8 meters per second squared. Right? Meters cancels out, second squared cancels out, and kilograms carries all the way through. And when you divide 1.4 by 9.8, you get 0.143 kilograms. And we need to round that to two significant figures because there's two sig figs in each of our given values. So we will round that to 0.14 kg. Okay. Again, it does not matter which way you solve it, you will still get the same answer. All right, thank you for watching.